Our project is heart rate monitoring system. Coming to point of monitoring, why should we monitor? In our world, more than 2 million people are at high risk of having heart attack. It would be helpful if we are able to monitor their heart rate continuously. Our project focuses mainly on finding a solution to this problem. The main aim of our project is to make a heartbeat detection and monitoring system using Arduino. The Arduino will detect the heartbeat using pulse sensor and will show the readings of SpO2 values and BPM on the LCD connected to it. We in this project are measuring the heartbeat using the IR pulse sensor and Arduino Uno. The timer we have set for counting the heartbeat is 10 seconds. There is a set point we can decide. After 10 seconds, the heartbeat would be shown on the screen.
This is Jeevan Kumar from Group 6. Now I am going to explain about the Proteus software and simulation part in this. This is the circuit we have made in Proteus software. This is the code which was kept for that. Now let us compile this code. Yeah, the compiling part is done successfully. Now let's see the simulation part in this. Here, now let's start the simulation here. Here in this LCD screen, three things are visible: current, heartbeat and time in seconds. After time reaches to 10 seconds, the heartbeat per minute will calculate automatically and show us the reading. Now by switching on this switch, we can see the readings here. As the time in 10 seconds goes to 10, then heartbeat per minute calculate automatically and show us. Okay, as time reaches to 10 seconds and the current heartbeat reading is 9, so heartbeat per minute reading gave as 54. This is the simulation part of Proteus software. Thank you all.
This is our hardware assembly. Components required for the hardware assembly are Arduino Uno, OLED display. This is heart rate and pulse oximeter sensor. This heart rate and pulse oximeter sensor is called MAX 30100. This sensor combines two LEDs, a photodetector, optimized optics and low noise analog signal processing to detect pulse oximetry and heart rate signal. Heart pulse sensor is biomedical sensor, which means it uses some biological and physiological variables to indicate the status of the body. Talking about variables, our sensor has analog output which goes from 0 volt to 5 volt, and this output indicates how much blood flow and pressure the heart is about to pump. But how does this sensor measure the blood flow changes? The sensor uses infrared signal from an infrared diode projected onto your skin. Just underneath your skin, there are capillaries carrying blood. Every time your heart pumps blood, there is a small increase in blood flow and pressure. This swells the capillaries slightly, and more filled capillaries reflect more infrared light. Infrared detector on the device senses the different reflected lights on the infrared level and amplifies the measured signal and convert it into interpretable voltage signal, which could be sent to any microcontroller like Arduino MCU. I am then using an OLED display where I plot the analog signal that I received from sensor. Working of pulse oximeter. A pulse oximeter is a device that is used to quickly and easily monitor a person's oxygen saturation. Pulse oximeter uses light to work out the oxygen saturation. Light is emitted from light source which goes across the pulse oximeter probe and reaches light detector. If a finger is placed between light source and light detector, the light will now have to pass through the finger to reach the detector. Part of the light will be absorbed by the finger and the part not absorbed reaches the light detector. Pulse oximeter uses the property that oxyhemoglobin and deoxyhemoglobin absorb light of different wavelengths in specific way. Oxyhemoglobin and deoxyhemoglobin absorb different amount of light at different wavelengths. Now, pulse oximeter emits two types of lights. One is red light with wavelength 650 nanometer and other is infrared light with 950 nanometers. Pulse oximeter works out with the oxygen saturation by comparing how much red light and infrared light is absorbed by blood. Depending on the amount of oxyhemoglobin and deoxyhemoglobin present in the blood, the ratio of amount of red light absorbed compared to the amount of infrared light absorbed changes. Pulse oximeter can then work out oxygen saturation. Factors that affect the accuracy of pulse oximeter reading: inaccurately position of pulse oximeter, nail polish or pigment on fingers, bright light on the probe. Other factors are patient moving, poor perfusion, carbon monoxide poisoning, skin pigmentation, skin thickness, current, tobacco use. These are the factors which affect the accuracy of pulse oximeter reading. When SpO2 ranges from 95 to 100%, it is termed as normal. When SpO2 ranges from 91 to 94, it is termed as mild hypoxemia. If SpO2 ranges between 86 to 90%, it is moderate hypoxemia. If SpO2% is less than 85%, it is severe hypoxemia. Person with severe hypoxemia should consult the doctor. Now coming to software, this is the code used. Verifying the code to check whether there are any errors in the code after compiling the sketch, uploading it into Arduino via cable. After uploading the code successfully to Arduino, we can see their light is blinking. Now we can check our heartbeats. Here we can see infrared light. We have to place our finger near infrared light to get the BPM. I had chosen serial plotter from the tools to check the sensor data. To use serial plotter, we must connect Arduino and PC via cable. Data is exchanged between serial plotter and Arduino via USB cable. In the graph, x-axis represents the time and y-axis represents the beat per minute. We can observe serial plotter is consistent. Since heart rate was taken by counting for 10 seconds, there is an error of plus or minus 6 BPM built in this procedure. SpO2 readings are 100% accurate. Checking the accuracy with the smartwatch, we have obtained 95% accuracy.
Now coming to the conclusion, the heart rate monitoring and pulse oximeter device available in the market have high pricing, whereas the device we designed is the cheapest one, and also the design proposes small size, lightweight, low power consumption and standardized signal processing capabilities. This device is also able to produce highly reliable test results for both heart rate and saturation of peripheral oxygen. In short, we call it as SpO2. Our design device has the advantage that it can be used by non-professional people at home to measure heart rate and SpO2 level easily and safely. Regarding future enhancements, this algorithm deals only with single patient and can be extended to multiple patients and doctors. Moreover, in future we can design PC software to analyze this received signal and generate the report, and this can be sent back to the doctor. With the connection established between two ends, we can also send patient's body temperature, blood pressure to the doctor's side.